Analyze the given figure. So we have this figure, okay, and answer the following questions. In the figure, A and B are slits and are d distance apart, okay. An is the path difference. So An, that is distance An, is the path difference, and we find in this question, okay, path difference An equals n times lambda, that is wavelength. So question A, what type of fringes is produced bright or dark at point P if n equals 2? So in this question, okay, we are provided with path difference, okay. So I'm writing over here, given path difference An equals n times lambda. So this is to be noted, okay, and this is the concept of this problem. Now we are asked to find what type of fringe is obtained at point P if n equals 2. So when we look into this setup, okay, when we look into this setup, we find this question is based on Young's double slit experiment. So I'm writing over here, okay, the given question, is based on Young's double slits experiment. So we have this. So fringes obtained at P can be bright or dark depending on the condition for constructive and destructive interference. So I'm writing the fringes, okay, the fringes obtained at P, okay, can be bright or dark depending on the conditions for constructive, okay, constructive or destructive interference. So we need to note this, okay. So what we find, we can have bright at P or dark at P. So that depends on the conditions, okay, for constructive or destructive interference. So we need to note this, okay. Now we know, okay, I'm writing over here, for constructive, okay, for constructive interference, path difference equals n times lambda. For destructive, okay, for destructive interference, path difference equals 2n minus 1 lambda by 2. So we have these two conditions for constructive and destructive interference, okay. So by constructive we mean maxima or bright, and by destructive we mean minima or dark. Okay, so this is to be noted. Okay, so this refers to bright or maxima, and destructive refers to, okay, so this refers to dark. Okay, dark or minima. So we have this. Now when we look into this, okay, figure, we have path difference equals n times lambda. Clear? So which is the condition for constructive interference. Therefore we get bright fringe at point P. So this is to be noted. Okay, so we get bright fringe at point P. So let us discuss the solution for A. Solution for A, given from question, okay, path difference an, okay, equals n lambda. So we have this, which is the condition for constructive interference. So we have this, therefore bright fringe, okay, bright fringe is obtained at point P. So this is to be noted. Okay, so what we find bright fringe, okay, is obtained at point P. Why? Because path difference is n times lambda, which is the condition for constructive interference. Now we know, okay, for constructive interference, okay, or from the condition for constructive interference, okay, so I'm writing over here, for constructive interference we have this, okay, path difference and what is path difference? Path difference is, okay, so path difference is small d times y divided by capital D. Okay, so this is path difference. So we need to note this. Okay, so what is y? Y is the position. Okay, let's say I'm drawing in this way. Okay, this distance is y. Okay, this distance is y. It is the position of bright at point P when we have constructive interference, or this represent the position of dark when we have destructive interference. Right now we are having constructive interference. For that reason, y represent the position of bright fringes. Clear? So we are going to discuss it in more detail. Okay, so we have this. So this equals n times lambda. So we have this. Clear? So this is the condition for constructive interference. So we have this. So this is to be noted. Okay, now I'm writing over here. Therefore, we can write DYN, okay, for different values of n divided by D n lambda. So we have this. Therefore, yn equals n lambda d by small d. So we have this. Clear? And the value of n equals 0, 1, 2, 3, so on. So we have this. Clear? So let us call it equation or relation 1. So this is relation 1. Now position of bright fringes. Okay, so I'm writing over here. Position of bright fringes are, let us find the position of bright fringes using this relation. Okay, for n equals 0 we have y0. Okay, we are going to put n equals 0 in this equation or relation. So since n equals 0, so the right hand side becomes 0. So this corresponds to the central. Okay, corresponds to the central bright. So this is for central bright. So O represent the central bright. So we need to note this. Okay, central bright. We are going to discuss it later on also. And for n equals 1, we have y1. So for n equals 1, this relation becomes lambda d by small d. Okay, so this is called first. This is called first bright. Okay, this is called first bright. So we have this. So this is the first bright. Okay, this is the first bright. And for n equals 2, see, for n equals 2, we have this in the question. So for n equals 2, we have y2. Okay, so we have y2. So this equals, from this equation, 2 times lambda d by small d. So this is the second bright. Okay, this is the second bright. So we have this. So I'm simply putting this in a box. Okay, I'm putting this in a box. So we have this. Now let us come to this figure. Okay, question A, what type of fringe? So we get bright fringe. Okay, at P. So P corresponds to bright fringe. For n equals 2, okay, we have this. And let us show this in the figure. Okay, so what we have bright fringe at P. Okay, so P corresponds to bright. Clear? I'm drawing roughly. Okay, so we have this. Clear? We have this. we have this. Now what we find is that, okay, this corresponds to central bright, okay, n equals 0 corresponds to central bright, and for central bright, okay, we have n equals 0. Now this, okay, this represent first dark, okay, it is first dark, it is first dark, clear? And this, okay, this fringe represent first bright, okay, so this is n equals 1 and this is first bright, this is first bright. Now this is n equals to second dark, okay, so this is second dark, and this is, okay, that is P, this is n equals 2, so we have n equals 1 first bright, now this is n equals 2, this is second bright, this is second bright. Similarly for this side also, okay, this side also, this represent, okay, this is first dark, n equals 1, this is first dark, clear? We have this. I am taking the points below O, okay, since we have point P below O given in the question, okay, so we have this, clear? Now we can see immediately after P, okay, so what type of fringe will be obtained immediately after P? So what we are getting immediately after P, we have dark fringe, okay, so this corresponds to, see, we have first dark, second dark, so this is n equals 3 and this is third dark, so we have this, which is the solution for question B, okay, so we have this. Therefore solution, okay, of B, what type of fringe will be obtained immediately after P? So third dark is obtained immediately after P, so I'm writing third dark n equals 3 is obtained immediately, okay, immediately after P. So we have this, okay, this is to be noted. Now C, okay, find the distance OP. Solution for C, distance OP, we are asked to find distance OP, and what we find, P represent the position of, okay, this represent the position of second bright, and position of second bright is y2, so I'm simply writing this distance, okay, OP equals y2, so we have this, so distance OP equals y2, and we know y2 equals, we have this, okay, this equals 2 times lambda capital D by small d. So the distance OP in the figure is this. Okay, so we have this.